Momentum and impulse, we will be looking at past paper examples. Just to recap the formulas, the first one's momentum, the second one's impulse, this is your F-net equation, and this is the most common one when there's a before and after scenario. The first past paper example reads, two friends on wheelchairs are playing on a surface where friction can be ignored. The combined mass of girl A and her wheelchair is 60 kgs, whilst that of girl B and her wheelchair is 85 kgs. Girl A moves to the right at a velocity of 0,60 and collides with girl B, who is stationary. Stationary means that the velocity is 0. After the collision, girl A and her wheelchair move with a velocity of 0,20 to the left in the same straight line. The first question, calculate the velocity of the friend on wheelchair B immediately after collision. You have all your values. The missing value is the velocity. You put it into the equation and you solve. And you get 0,57 to the right. Now, you have to take a direction. Like I've mentioned in the previous videos, you have to take a direction because momentum and impulse always has direction. So in this case, we're taking right to be positive. So if you come out with a positive answer, you know that she's moving to the right. If you come out with a negative answer, you know she's moving to the left. The next question, determine by means of a relevant calculation whether the collision was elastic or inelastic. The first thing you do always is your kinetic energy. You do it on this side and you do it on this side. So you make two sides to this answer. You do kinetic energy initial, kinetic energy final or after. You substitute your values and you see this comes out to 10,80 and this comes out to 15,01. Because they don't equal each other, the collision is inelastic. Let's move on to the next past paper example. A cricket ball of mass 0,15 kgs is dropped from rest, meaning 0, from a height h. It reaches the ground with a speed of 6,2 and is in contact with the ground for 0,02 seconds. The ball bounces straight upwards with a speed of 3,62. Ignore the effects of air resistance. Calculate the magnitude of the momentum of the ball when it reaches the ground. The first thing you do is choose a direction. I'm going to choose downwards as positive. Let's have a look. We have your F-net equation, you have your mass, and you have your velocity initial, and you have your final velocity, so you just substitute it into the equation. Now you're left with negative 1,47. However, we chose downwards as positive. If we get a negative answer, it means that the ball is actually moving upwards. So it's 1,47 upwards. Moving on to the next example, a car of mass 1,200 traveling east with a speed of 25 collides with a mass of 1,800. The van of mass 1,800 is stationary on a frictionless track. Stationary meaning the velocity is 0. The two vehicles move together as a unit after the collision. The first question, calculate the speed of the vehicles after the collision. Just a reminder, please take your direction first. The next thing you do is write your formula and fill in all the values. 0 because they tell you it is stationary, and this is written in this format since they move as a single unit, thus you add their masses and there's only one velocity. The next question, determine by means of a relevant calculation whether the collision was elastic or inelastic. If you've watched any of my previous videos, you would know exactly how to do this. The first thing you do is work out your kinetic energy initial and kinetic energy final. Then compare your two answers. If they aren't equal, it is inelastic, like in this case. This is an unusual example. A ball X of mass 10 is moving eastwards with a velocity of 2. It collides elastically with another ball Y of mass 2, which was moving with an unknown velocity. Immediately after the collision, ball X comes to rest and ball Y moves eastwards with a kinetic energy of 36. Calculate the velocity of Y. The first thing you do is take direction. Now, think about this. They say elastically. Whenever you see this concept, you always do kinetic energy initial and kinetic energy final. So you write the formulas for this. Here are the formulas, and now fill in what you know. So, you know this is 0 because it says comes to rest over here. And then you fill in all missing values, and you see 1 is unknown. You make this the subject, and you solve for your velocity.